Assalamualaikum warahmatullahi wabarakatuh. My name is Muhamad Amir bin Abdullah. I'm from Bachelor of Surveying Science and Geomatics, and today I'm going to present my research, which is estimating groundwater storage changes using GRACE and GLDAS data in Google Earth Engine over the state of KEDAH. The presentation outline for our agenda today is starting with introduction and an objective, study area, methodology, result and analysis, and followed by conclusion and recommendation. So let's start with the introduction. Groundwater is one of the most important freshwater resource and widely used for domestic, agriculture, and industrial. However, groundwater availability has been affected by human activities and climate variability. So, conventional groundwater monitoring depends on observational wells, which require high cost, time, and manpower, and only provide information at limited location. So that's where satellite gravimetry, such as GRACE, which provides an alternative approach to estimate groundwater storage changes over large areas efficiently. So let's move on to aim and objective. Our aim and objective is very simple and straightforward. So it is to estimate groundwater storage changes by using GRACE gravimetry data in KEDAH. An objective is to identify groundwater storage changes using gravimetry data provided by GRACE. To the study area, the selected study area is KEDAH, which is located at northern region of Malaysia. So, as we know, KEDAH commonly known because of their agricultural activities, particularly paddy cultivation, which depend heavily on groundwater. So let's move to the next part, which is methodology. The methodology consists of four main phases, which is first is data acquisition, where GRACE and GLDAS datasets were obtained. And second is data pre-processing, where all the dataset were processed and clipped to the KEDAH boundary for more precise assessment using Google Earth Engine. And third is data processing, where groundwater storage changes were calculated by subtracting soil moisture and canopy water storage from terrestrial water storage. And final is the result were analyzed and present as groundwater storage changes to the result and analysis. The main result of the research is the groundwater storage changes map of the years of 2010 until 2020. This map illustrates the spatial distribution and temporal variation of groundwater storage changes across the This map show the groundwater storage changes in 2010. Most districts were recorded negative groundwater storage values. However, as we can see, Pendang and Yan show relatively higher groundwater storage compared to the surrounding districts. So overall, the groundwater storage condition in 2010 were considered stable. Experienced lower groundwater storage than 2010. The reduction became more noticeable, especially in the central and eastern parts of Kedah. This indicates that groundwater storage had started to decline or decrease in several districts. By 2020, groundwater storage showed the largest decrease among the three study years. Most districts record negative groundwater storage values, and Bali record the highest groundwater storage decline, while almost all districts show a decreasing groundwater storage condition. This shows that groundwater resource became more depleted over time. This study successfully estimated groundwater storage changes over Kedah using GRACE and GLDAS datasets in Google Earth Engine. The result indicate that groundwater storage generally decreased from 2010 to 2020. Among all districts, Baling experienced the greatest groundwater storage decline in 2020. The study period can be extended by using a longer time series to obtain a more reliable trend analysis. Higher spatial resolution datasets can also be incorporated to improve the accuracy of groundwater estimation. In addition, integrating inside groundwater monitoring data will provide a better validation and support for groundwater resource. That's all from me, and thank you for your attention.